This is the fifth lesson from chapter 16, and we're going to mainly look at previous exam questions today. So I'm going to look at the miscellaneous exercise and those OCR questions. Now we're going to try and find the area between this straight line and this curve, but they've not given us very much information, and they have told us that this line has a gradient of 3. So if we could find a point that lies on that line, then we could use the point slope formula. What we do know is this line coincides with the minimum of this graph. Now to find a minimum we could differentiate this, or as this is in vertex form, we can just say straight away what the vertex is. So 2, 1. Actually it says that the slope is 2 there, whoops. So if we use the point slope formula, y minus the y value equals the slope x minus the x value, and then distribute this, and then simplify, we get y equals 2x minus 3. So f of x, when we find the area between two curves, we do the integral of f of x minus g of x. So f of x, the top one, would be 2x minus 3, and then g of x would be this curved part here, x minus 2 squared plus 1. So that's what we actually want to do. Now the problem is, we don't actually know the limits right now. They haven't told us what a and b are. So we're going to need to try and figure out what those are. First of all, I can certainly substitute in for my f of x, which we just worked out, and also for g of x as well. And I could go ahead and integrate as well, but I certainly don't know at the moment what is the intersection for these 2 points, so I'm definitely going to have to work that out. So to find the intersection, what I really want to know is where do these two graphs intersect? Where does this intersect with this? So let's look at that on the next slide. So if I set them equal to each other, distribute, doing FOIL, and then add 1 onto my answer, rearrange this equal to 0, and then this should factor, and therefore we got our 2 answers. So our limits for this question are 2 and 4. Strictly I only need the x limits, but we could find the y values by substituting back into this formula up here if necessary. So we found what the p is and we found out what q is, so we should have all the information we need now for this question. So we should be able to go ahead and solve. So this is the part that we were at before. We'd already integrated, and let me go back a step. There we go. We'd already integrated, and when you actually talk about how we integrated, so the integral of 2x is obviously x squared, the integral of 3 is 3x, and for this one here I use the chain rule, increase the power by 1, divided by the new power, and then also divided by 1 as well, because that's the differential of x minus 2, and the differential of 1 is x, and I made sure I put parentheses around all of this. Okay. So we're focused on this side here. We're going to plug 4 and 2 into that formula. If we plug 4 in, we get this, and if we plug 2 in, we get this. And then negative 8/3 take away negative 4 is 4/3, so that is our answer for this question. Now, alongside here, you'll notice there's another method as well. So actually, rather than doing the chain rule on this separately, I actually went ahead and subtracted these two terms. So I worked out what is f of x minus g of x and got this. Then you can integrate that as well. Plug in the two numbers, and you still end up with 4/3. So there is a couple of different ways that you can actually answer this question. You can go ahead and integrate f of x minus, you can go ahead and integrate g of x and then plug the numbers in, or you can go ahead and simplify this first and then integrate, but you should still end up with the same answer if you do that. And I just think I believe I just separated that so you can see that a little clearer if you prefer. Now you could also do the same question using geometry as well. So this shape here, oops, it's the area of a trapezoid, or trapezium for ace I guess. Take away this area here, which is the integral. So I would still have to figure out all that stuff that I found out before, what is the intersection, and I would still have to find out what that equation is to do that. So we already did that on a previous one, so we can go ahead and work that out straight away. So we already worked out the limits for 2 and 4. I also said the y values weren't important, but they are if you want to find the area of that trapezium. So if we want to find the area of the trapezium, we can use a half base 1 plus base 2 times height, plug that in, and then we end up with 6. We can go ahead and work out the integral for this part here. Remember, this is just x minus 2 all squared plus 1. and then go ahead and integrate that, and we get an answer of 14/3. And if we go back to our original picture, if we want to find that specific area, we can do the area of the trapezium, take away the area under the curve, and you end up with 6 take away 14/3, which once again is 4/3. So essentially 3 different ways of doing the same question. I would probably frown upon this last way. If possible, much better to do f of x minus g of x for 2 curves. But sometimes if you've got an easier shape, that method is worth thinking about. If there's an obvious area you can find, try and do that rather than doing 2 separate integrals. And the questions for this one, I think you should finish off the rest of 16D, which is 7 and 8, and then do the miscellaneous exercise from 16, but only the OCR questions.